Hello Geometry, this is a series of videos. This one is for lesson 6.3. You'll see another video for lesson 6.6, but focusing on 6.3, we're going to start our discussion about the phrase necessary and sufficient. I'm going to be using this phrase a lot. In this video, I'm focusing on what is sufficient. What is enough to prove that something is a parallelogram? In this section, we're focusing on that shape in particular. What's necessary is that the lines are parallel. You have two pairs of parallel lines. That's what's necessary. But there's other ways to go about that. For example, I know that if opposite sides are congruent, then that's part of being a parallelogram. I also know that if same side interior angles have a sum of 180, then I know that I have some parallel lines, which is what happens in a parallelogram. But what you're going to find is that this side is not sufficient. Why not? Well, because with these two having a sum of 180, all right, that tells me that for this transversal, I can say these are parallel, but that is not sufficient because that's only one pair of parallel lines. So we need to have a little bit more. For example, I'd need to know that 1 and 3 are also supplementary. That would prove the other pair. And to know that, I'd need to know that 2 and 3 are the same. That'll come up in another theorem here. But what I want to focus on is the theorem 6.5, which deals with this side over on the left, that opposite sides are congruent. That is sufficient to prove that it's a parallelogram. So I want to look at the proof of this. Okay, first we'll start with the theorem. We know that if it's a parallelogram, then we have opposite congruent sides. Okay? But we need to prove it is as the converse. Is it true that if opposite sides are congruent, then it has to be a parallelogram? Okay, that's the idea of, is that sufficient enough? Is that enough information to know that it's a parallelogram? So this is where we try to prove the converse. So if I have opposite sides that are congruent, is that enough to prove that I've got a parallelogram? So what's necessary to prove here? It's necessary to prove that these are parallel. That's what I need. That is necessary. So the idea is, are these statements sufficient for proving it's a parallelogram? So let's see. We can draw this diagonal. Okay, we draw the diagonal, and we know that opposite sides are congruent. Okay, so by side, 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 we have this side, and this side equal to this side, and this side. Okay, so that's enough to prove that I have equal angles. And since the angles are equal, okay, WXZ would be this angle right here and this angle right there. With this transversal for this angle and this angle, I'm talking about these sides. Okay, so these sides are congruent based on these angles. And I can say the other sides are parallel based on those angles being congruent. So I need it. It's necessary to prove both are parallel. And now I have enough to say it's a parallelogram. So this statement, these two statements of congruency, are sufficient for proving that it's a parallelogram. You're going to see a couple more proofs, Theorem 6.6 and Theorem 6.7. One of them you'll have to do on your own in an exercise. Okay, and that would be a great place to start. Exercise 12. Good luck with that, and I'll see you in the next video.